Okay, we're going to look at horizontal stretches, compressions, and reflections, which is a little different from anything we've done in grade 10 because we only kind of focused on vertical horizontal stretches and compressions. And there's a reason for that, and we'll kind of get into it. But what it is this value. Anytime we have a value within whatever the function is, multiplied by the variable in the function, it will cause a horizontal stretch, compression, or reflection, which sounds very, very confusing, especially because what the heck does this f mean? Well, this f essentially means you can apply this rule to any function that you're given. So this represents all possible functions. So the idea is, one that we're much more familiar with using is maybe a parabola, right? We have y is equal to x squared. Okay? Now we know vertical horizontal compressions and stretches is a is kind of outside of this, okay? Kind of outside of our x, and then our x is squared. So I want you to keep in mind that this a is outside of the bracket, and anything within the bracket is affected by that squared, okay? If I was to write the same thing with a horizontal compression, y is equal to kx squared. So the k is actually inside of our function, okay? And that's why they've kind of written it inside the bracket. So I'm just trying to relate to parabolas here, and I'll show you how it affects other functions, okay? Which is a little different from what we're used to seeing. This is going to change a lot of things, okay? Essentially, it's going to compress and stretch things, well, horizontally, okay? So anytime we have a k value, okay, greater than 1, we're going to have a horizontal compression, which is the opposite of what we're used to. If you remember A, we have a vertical stretch up and down. Okay, so because it stretches, well, K actually goes left and right, and it's actually compressed. When the K value is less than 1 but greater than 0, so a decimal or fraction less than 1, we get a horizontal stretch. Okay, so again, it's horizontal, but I want you to think like maybe I'll use a line here. These lines might be good representations, or dots at both ends of them. In a horizontal compression, think of like you're pushing it inwards from these sides, okay? Where in a horizontal stretch, okay, we're actually taking these values and pulling them outwards, okay? That would be the effect of that idea. So we'll play with a function and notice the differences to it. The other note that's really important for horizontal is, say you have the original equation and you have the two coordinates, and then there is some k value, so there's some horizontal stretch to it. A quick way of figuring out where those old coordinates end up is you take the original x values and you divide them by your k. Okay? So what I'm going to do is I'm going to play with two parabolas, and then I'm going to put them through this kind of process here. Okay, so I'll bring up a graphing equation here. And in the first one we have 2x squared. And maybe, you know what, I should actually put the original so that you can kind of see the differences here. Okay, and we'll turn off this one to start. A vertical stretch, okay, and hopefully this is something we're a little more familiar with. I'm going to bring up some markers to draw with on this page here. A vertical stretch, okay, so where we have 1, when we square 1, we end up at 1. So this coordinate here is essentially -1 and 1, okay? But when it's vertically stretched, okay, we take this point and we essentially multiply it by the a value. Why did that turn off? Thank you. Okay, we multiply it by our a value. That's our y, of course. Okay, we multiply it by, in this case, 2, and our new a value is at the value of 2. So we have -1 and 2 as our coordinate. Does that make sense? Yeah. This is a vertical stretch. So we've taken this, okay, this parabola here, and we've pulled it on both ends, upwards and downwards. So I want you to think about that. So that's a vertical stretch. Okay, now let's turn that off. We'll get rid of that guy. In this one, we have a horizontal compression. Now it looks very, very similar, and we'll bring that one up. It looks like it's just a little more pronounced, and we've used the same number too, so it's kind of confusing to why it would look more pronounced. But in this case, we take our values, okay, so same value. In fact, I'll use this side for a coordinate of 1 and 1. But because it's affecting the x value here, we're taking that 1, okay, and we're dividing it by our k. And in this case, k is equal to 2. Can you see that? Yeah, that's fine. So we take this coordinate, and we have 1, well, divided by 2, which is going to be a half, right? So we now have the coordinate of 1/2 and 1. So 1/2 and 1 is our new coordinate. So it's been pushed inwards. And the same thing happened over here. It's been pushed inwards that much. So this new parabola looks like it's been horizontally compressed, even though the effect of it is very similar to a vertical stretch. It's been pushed inwards, and it's a little more pronounced if you notice, and that's because that squared is going to affect that number. Okay. So since we have that idea of horizontal stretch and compression, the last thing is that when our k value, I'm just going to say when a k value is a negative, it's reflected on the y-axis. Okay, so, and again, this will be kind of hard to see, especially with a parabola. But let's say I now make this bracket negative 2x squared. Well, I ended up on the exact same spot, right? Well, that's because this is the axis of symmetry, and since we reflected on it, because it's a symmetrical shape, it doesn't physically look like there's any difference with that negative, okay? Vice versa, though, if you remember with a vertical flip, okay, it completely changed the parabola. It flipped it on the x-axis, sending it downwards. That's what the orange one is. Horizontal one sends it this way. So let's say I work with a function. I'm going to pull all of these off. I'm going to use a different function. Let's say I do the square root of x, okay? This is one where you'll actually see a reflection on the y-axis. If I take this same thing, but instead I say negative x, it's now going the other way. It's been reflected on that y-axis there. Okay, does that make sense as reflections? Anytime it's negative, it reflects on the y-axis rather than the x-axis from before.